Assalamualaikum warahmatullahi wabarakatuh and good day everyone. My name is Muhammad Muaz bin Muhammad Rafiq. My metric number is 2025484384. Today I would like to present the background of our project, the Halal Smart Box Sensor. Food spoilage is a major challenge in food storage and distribution, especially for perishable food such as meat, fish, dairy product, fruits and vegetables. It leads to food waste, financial loss and health risk to consumers. Traditional method of checking food freshness such as appearance, smell, texture and expiry date are often subjective and may not reflect the actual condition of the food. To solve this problem, our project introduced the Halal Smart Box Sensor, an IoT-based smart food storage system. It used an MQ135 smart food storage. It used an MQ135 gas sensor to detect spoilage gas such as ammonia, while an ESP8266 not MCU continuously monitor the gas levels. The data is sent to the Blink IoT application through Wi-Fi, allowing users to monitor food freshness in real time. If the gas level exceeds the safety threshold, the system activates a buzzer and sends a notification to the user's smartphone. Overall, this project helps improve food safety, reduce food waste, and preserve the freshness and quality of store food. Thank you. Next, I will explain the problem statement of our project. The first problem is difficulty in identifying the early stage of food spoilage. Food can begin to spoil before any visible change in color, smell and texture appear, increasing the risk of consuming unsafe food. The second problem is the reliance on manual methods such as smelling, touching or checking the expiry date. These methods are subjective, inconsistent and cannot continuously monitor the condition of the food. Another issue is that conventional food storage boxes do not provide real-time monitoring or remote notification. As a result, users may not be aware when food starts to spoil, especially when they are away from home. Lastly, the delayed detection of spoiled food may cause health risk, unnecessary food waste and financial loss. Therefore, a smart monitoring system is needed to improve food safety and reduce food wastage. Okay, next we go to the last session of 1.0, that is the objective and significance of our project. The main objective of this project is to understand the challenge in identifying spoiled foods during storage. We also aim to develop a halal smart box sensor using the MQ135 gas sensor and ESP8266 not MCU with IoT technology. In addition, the system provides real-time monitoring and instant alert through the Blink IoT application. Lastly, we evaluate the effectiveness of the system in detecting food spoilage based on gas concentration. The significance of this project is that it enables the early detection of food spoilage through continuous monitoring, helping to improve food safety and preserve food quality. Unlike conventional storage methods that rely on manual inspection, this system automatically sends alert through a buzzer and the Blink IoT application whenever unsafe conditions are detected. As a result, users can take immediate action to prevent food spoilage, reduce food waste and financial loss, while supporting halal food preservation through the application of IoT technology. Thank you.
Assalamualaikum warahmatullahi wabarakatuh, and I am Muhammad Aman, and I will explain the system requirement and specification for our project, which is the Halal Smart Box Sensor. The Halal Smart Box Sensor is an Internet of Things or IoT based on food storage system. Its main purpose is to monitor food freshness by detecting gases released from spoiled food using a gas sensor. When the gas level exceeds the safe limit, the system immediately activates a buzzer to alert nearby users. At the same time, the data is sent through Wi-Fi to the Blink mobile application, allowing users to monitor the food remotely and receive notification. The system specification explains how the device functions, including gas detection, wireless communication, power supply, and monitoring. Meanwhile, the system requirement describe the hardware and software needed to ensure the system works accurately, efficiently and reliably modern family life. Next, I will explain the functional specification of the system. First function is the food spoilage detection. The MQ135 sensor continuously detects gases released by spoiled food. Next, the system compares the gas concentration with a predefined threshold to determine whether the food is still safe. If the gas level exceeds the threshold, the buzzer is activated immediately to alert nearby users. At the same time, the sensor readings are transmitted through Wi-Fi to the Blink application. The system also sends a notification to the user's smartphone whenever spoilage is detected. In addition, users can monitor the gas reading and system status in real time through both the Arduino IDE serial monitor and the Blink application. Lastly, the system performs continuous monitoring automatically, so users do not need to check the food manually. So next is the hardware requirement used to develop the HALAL Smart Box sensor. So the main component is the MQ135 gas sensor, which detect gases released by spoiled food such as ammonia and carbon dioxide. The DHT11 sensor measures the temperature and humidity inside the storage box to help monitoring conditions that affect food freshness. Next, the MCU ESP8266 acts as the main controller, processing sensor data and transmitting it to the Blink application through Wi-Fi. So next is the buzzer. The buzzer provides an audible alert while an LED gives a visual indication when spoilage is detected. Jumper wires, a resistor and a USB cable are used for circuit connection and power. Next is laptop. Laptop is used for programming and testing. A smartphone display notification through Blink. And lastly, the plastic box serves as the enclosure. So the total hardware cost is approximately 57 ringgit. In this slide, I will explain the similarities between the existing food storage system and our proposed HALAL Smart Box sensor. Both systems have the same goal, which is to ensure food remains safe for consumption. In terms of food freshness detection, both help determine whether food is still edible. However, existing method rely on operation date, appearance, smell or manual inspection, while our system automatically detects spoilage gases using the MQ135 gas sensor. For monitoring, traditional system require users to check the food manually, whereas our system continuously monitors the gas level inside the smart box. Both systems also alert users when food is spoiled. Conventional method depend on visible change, while our system provide instant alert through a buzzer and the Blink mobile application. In conclusion, although both systems share the same purpose of improving food safety, the HALAL Smart Box sensor is more efficient because it uses IoT technology to provide automatic detection, continuous monitoring, and real-time notification.
First, let me explain the system design of our HALAL Smart Box sensor. The main controller of system is the ESP8266 node MCU. It acts as the brain of the system by collecting data from the sensor, processing the information, and sending the data to the Blink Cloud platform. Our system uses two sensors. The DHT11 sensor measure the temperature and humidity inside the refrigerator, while the MQ135 sensor detect gas that may indicate food spoilage or contamination. Based on the process diagram, when the system starts, the node MCU first connect to the Wi-Fi network and install all the sensor. Next, it's continuous reach the temperature, humidity, and gas value. The system when compress this reading with predefined threshold value. If all reading within the safe range, the data is uploaded to the Blink application so user can monitor the refrigerator in real time.
However, if the temperature becomes too high, to humidity becomes too low, or the gas level exceed the safety limit, the system immediately active the buzzer and sends a notification to the user smartphone. This enables user to take immediate action before food spoilage occurs. Next, I will explain the secure design and IoT components used in this project. The most important component is the ESP8266 Node MCU, which controls the entire system and provide Wi-Fi connectivity. The DHT11 sensor is connected to the Node MCU to monitor temperature and humidity. The MQ135 gas sensor is connected to the detect gas that may be produced by spoiled food. We also use a buzzer as an alarm when the sensor reading access the safe threshold. The buzzer sound immediately to alert nearby user or sensor reading and transmitted through the Wi-Fi to the Blink cloud server. Using the Blink mobile application, user can monitor the temperature, humidity, gas level, and alarm status from anywhere with an internet connection. Therefore, this IoT system provide real-time monitoring, remote access, and early warning to help maintain the quality and safety of halal food storage. Lastly, I will explain the programming of our system. The programming is developed using the Arduino IDE with C++ programming language. When the system is powered on, the Node MCU first connect to the Wi-Fi network and Blink cloud server. After the connection is established, the system continuously reads data from the DHT11 and MQ135 sensor. The program is compare each sensor reading with predefined threshold values. If the temperature exceeds 35 degrees Celsius, the humidity falls below 14%, or the gas concentrate becomes too high, the Node MCU immediately active the buzzer. At the same time, the system send a push notification through the Blink application and updates the latest sensor reading to cloud. Its reading remain with the normal range. The system continues monitor and update the Blink dashboard in real time. This programming logic allow to system to monitor food storage condition continuously and notify user immediately. Whenever an abnormal condition is detected, so that's all for me.
Assalamualaikum, my name is Yofahan Nabi Kamel. I will explain the test execution of our smart halal food storage monitoring system. The testing was conducted to verify that the system functions correctly and meets all the project requirements. The system was tested under both normal air, which is normal air condition, and simulate gas condition to evaluate its performance. During the testing process, we monitor the system response using the Arduino IDE serial monitor, the buzzer and LED indicator, and the Blink mobile application to ensure that it will use in this project. All tests were carried out in a controlled environment that simulate a food storage compartment to ensure consistent and reliable result. Before the testing began, the MQ135 gas sensor was allowed to warm up for several minutes to obtain stable and accurate reading, which is expose the sensor to simulate gas source such as strong odor and vapor to mimic the gas released by spoiled food. Alright, we test the Blink notification feature to ensure that user receive instant alert on their smartphone even when the Blink application is running. It confirms that the reliability of the system real-time monitoring and ensure notification capabilities to ensure that the product is in safe condition. So next, I will present about software and hardware testing. First, the Wi-Fi connection was tested and not MSU successfully connecting to Wi-Fi manager to ensure that the auto connect and captive water feature work as expected, providing a stable internet connection. To ensure that the Blink IoT platform successfully receive real-time sensor data and alert notification will deliver instant to the smartphone, which is whenever unsafe gas level will detect. For the Arduino Uno and serial monitor, the program compile and upload without any error. The serial monitor display the gas level, temperature, humidity, and detection time according to real time. The MQ135 gas sensor require to 3 to 5 minute warm up, which is period before stabilizing to ensure the food in good condition. After that, it successfully detect gas from simulate spoiled food, with reading increasing above the percent threshold when the gas concentration exceed the threshold of 300. The pressure buzzer was activated immediately and produced a clear repeating beep beep alarm to warn the user. The DHT11 sensor also performed well by providing stable and accurate temperature and humidity reading throughout the testing. Finally, the LED indicator remain off under normal condition and blink continuously whenever unsafe gas level detect. Provide a clear visual warning. Overall, all components function successfully, demonstrating that the system is reliable for monitoring food storage condition, also provide real-time alert to user. Alright, next I will explain about result analysis. Based on this testing result, the system performed successfully and achieved all of the project objectives. The MQ135 gas sensor was able to reliably detect gas released from spoiled food after warm-up period of about 3 to 5 minutes. At the same time, the HT11 provide stable and accurate temperature and humidity reading, allowing the system to continuously monitor the food storage. Whenever the gas concentrate exceed the preset threshold of 300, the system respond immediately by activating the LED indicator, and the piezo buzzer also helps sending a real-time notification through the Blink application. In addition, the SP82066.MCU successfully transmit the gas level, temperature, humidity, and detection time to Blink IoT platform in real time. Ensure that user could monitor the storage condition remotely, and in conclusion, the system successful achieve all project by accurate monitoring food storage condition, detecting early sign of food spoilage, and providing reliable real-time alert to help user avoid consuming unsafe food.
So the first challenge is sensor calibration. The MQ135 gas sensor requires a few minutes to warm up before it can produce stable and accurate readings. During the beginning of our testing, the sensor values keep changing, making it difficult to determine whether the food was actually fresh or spoiled. After the warm-up period, the readings became much more stable and reliable. So the second challenge is environmental influence. The MQ135 sensor is sensitive to different types of gas, not only gases produced by spoiled food. For example, smoke, cleaning chemicals, or strong odor nearby can also affect the sensor readings. This may cause false alarm if the threshold value is set too low. Therefore, choosing the appropriate threshold is very important to ensure accurate spoilage detection. The third challenge is internet connectivity. Since our project used the Blink IoT platform, the system depends on a stable Wi-Fi connection. During testing, we noticed that if the internet connection became weak, the notification sent to the smartphone was slightly delayed, although the buzzer and LED still work immediately. Therefore, a stable internet connection is essential for effective remote monitoring. In conclusion, the HALAL Smart Box sensor was successfully developed to detect the early signs of food spoilage using IoT technology. The system provides real-time monitoring and instant notification through the Blink application, allowing users to identify spoiled food more efficiently. Overall, this project helps improve food safety, reduce food waste, and demonstrates the practical application of IoT technology in smart food storage system.